Today we are going to discuss about magnetic separation and extraction of metals. Okay, from Unit 1 Metallurgy. Unit 1 Metallurgy. So first magnetic separation papa. Okay, so in this magnetic separation process, applicable to ferromagnetic wars only. Ferromagnetic wars only. This is applicable to ferromagnetic force. Magnetic force. Ferromagnetic force only. And then this process is based on difference in magnetic properties of the ore and in impurities. Difference in magnetic properties of the ores. Magnetic properties of the ore and impurities. Okay, so this process is applicable only ferromagnetic force, and this process is based on difference in magnetic properties of the ore and impurities. Okay, for example, tin stone can be separated from the wolframite. Tin stone can be separated. Tin stone can be separated from the wolframite. Wolframite impurity. Wolframite impurities. Similarly, tin stone can be separated from the wolframite impurities. Okay. Similarly, chromite ores. Chromite and pyrolusite. Chromite and pyrolusite. These two and the ores. Okay. This is the magnetic property. So wolframite is also magnetic properties. So tin stone and chromite pyrolusite. So chromite and pyrolusite can be separated from the siliceous impurities. It can be separated from the siliceous impurities. Siliceous impurities. Okay, so first one, this process is applicable to ferromagnetic ores only and based on a difference in magnetic properties of the ore and impurities. And for example, tin stone can be separated from the wolframite impurities, and the chromite and pyrolusite can be separated from the siliceous impurities by using this process, means magnetic separation process. How to do the process? எப்படி செய்யலாம் இந்த process எப்படி பண்ண முடியும் நம்மள பார்த்தோம்னா, first of all we have to take a crushed ore. crushed ore எடுத்துக்கணும், சரியா? So crushed ore poured on an electromagnetic separator. Crushed ore poured on an electromagnetic separator. So the electromagnetic separator is consisting of two rollers. So consisting of belt moving over the two rollers. Okay, let's move like this direction. This is two rollers. It has two rollers. One is magnetic and other one is non-magnetic. So this is magnetic roller. This is magnetic roller. This is non-magnetic roller. This is non-magnetic roller. Okay, this is magnetic, this is non-magnetic roller. When crushed ore poured onto an electromagnetic separator, என்ன பண்றோம்? crushed ore இத அப்ளை பண்றோம் இல்லையா? இப்போ என்ன ஆகும்? ரோலர் இந்த டைரக்ஷன்ல ரொட்டேட் ஆயிட்டு இருக்கு. அப்போ என்ன ஆகும் particles this particle crushed ore contain magnetic parts of the material and also non-magnetic parts of the material ரெண்டு contain ஆகும் so magnetic parts இருக்கும் non-magnetic parts இருக்கும் இல்லையா அப்போ வரும்போது only the magnetic parts of the material magnetic parts of the material attract towards the magnet. This is magnet, yeah. So iron particles are attract pannom. So magnetic part of the material attract towards the magnetic material and falls as a heap. Falls as a heap. சின்ன குவியல் மாதிரி கிடைக்கும். So falls as a heap near to the magnetic region. இது பக்கத்திலே collect ஆகும். And then non-magnetic parts of the ore has collected as also heap. Okay, இது நமக்கு சின்ன குவியல் மாதிரி தான் கலெக்ட் ஆகும் பட் away from the magnetic region. This is magnetic region இல்லையா this is magnetic region but away from the magnetic region ல நமக்கு இது கலெக்ட் ஆகும் non magnetic ores கலெக்ட் ஆகும் okay so first என்ன செய்யணும் the crushed ore is poured onto an electromagnetic separator. This is electromagnetic separator consisting of belt moving over the two rollers. One is magnetic roller and other one is non-magnetic rollers. When the crushed ore contain magnetic ores and also non-magnetic ores or material. So magnetic part of the material is collected or attracted towards the magnet and collected as a heap collect ஆகுது near to the region of magnetic region collect ஆகுது and then non-magnetic part of material is collected as a heap away from the magnetic region. இல்லையா ஸோ ஏன்னா இது ஆப்சன்ஸ் ஆஃப் மேக்னெட்டிக் பார்ட்ஸ் மேக்னெட்டிக் பார்ட்டில் ஆப்சன்ஸ் ஆகிருக்கு இல்லையா அப்போ என்ன ஆகாது இதனால மேக்னெட்டால இது அட்ராக்ட் ஆகாது இதில் மட்டும்தான் மேக்னெட்டிக் பார்ட்டிகல்ஸ் இருக்கு ஸோ அட்ராக்ட் ஆகுது அதனால தான் என்ன சொல்றேன்னா திஸ் ப்ராசஸ் ஒன்லி அப்ளிகபிள் டு ஃபெர்ரோ மேக்னெட்டிக் கோர்ஸ் ஸோ அயன் பார்ட்டிகல்ஸ் இருக்கிற காம்பவுண்ட்ஸ் தான் மேக்னெட்டிக்கலை அட்ராக்ட் பண்ண முடியும் இல்லையா அதனால தான் நம்ம அப்ளிகபிள் டு ஃபெர்ரோ மேக்னெட்டிக் கோர்ஸ் வந்து அப்ளை பண்ண முடியும் ஸோ நான் மேக்னெட்டிக் பார்ட்டிகல்ஸ் இஸ் அவே ஃப்ரம் த மேக்னெட்டிக் ரீஜன் தள்ளி விடும் ஸோ magnetic particles attract towards the magnet so falls as a heap near to the magnetic region. So this is a magnetic parts or material. Magnetic parts or material. This is non-magnetic parts or material. Non-magnetic parts or material. Okay, so this is a magnetic separation process. Okay, so this process is only applicable to ferromagnetic ores and based on a difference in magnetic properties of the ore and impurities. Okay, for example, thin stone can be separated from the wolframite impurities and chromite and pyrolusite can be separated by using from siliceous impurities by using a magnetic separation process. And how did the process pathona the crushed ore poured onto an electromagnetic separator consisting of two rollers moving belt over the two rollers. So one is magnetic, this is magnetic. So one is magnetic, other one is non-magnetic. So crushed ore contain magnetic parts of the material and also non-magnetic parts of the material. So magnetic parts of the material once they attract towards the magnet, so it falls as a heap near to the region of magnetic region collect ஆகுது. On non-magnetic parts of material is collected as a heap away from the magnetic region. Okay, so this is the magnetic separation process. Okay, next one, extraction of crude metals. So extraction of crude metals extracted from the concentrated ore. Concentrated ores. Okay, so this process carried out in two steps. This is two-step process. The first of all, the crushed ore is converted into its oxides. Convert பண்ணும் and then the oxides of ores is converted into elemental acids by using reduction process. Okay, this is a two-step process. The first step is conversion of ores into oxides of metal of interest. Oxides of metal of interest. Oxides of the metal of interest. and then this metal oxides is converted into its element state by using reduction. So reduction of oxides or metal oxide. Metal oxides is converted into its elemental state. Okay, these two steps is very important for further reactions. Okay, so this is the conversion of extraction of crude metals. And then according to principles of thermodynamics, என்ன சொல்றாங்க பார்த்தோம்னா, reduction of oxides is easier when compared to reduction of other compounds. Okay, reduction of oxides is easier when compared to other compounds. In the concentrated ore, metals exist in positive oxidation state. So metal exists in positive oxidation state. So in the ore, in the ore concentration of the ore exists in metal exists in positive oxidation state. Positive oxidation state la irukum. Enna panumna, it's to be reduced to its elemental state. The positive oxidation state convert பண்ணனும் பார்த்தனா, it's element state convert பண்ணனும். Elemental state convert பண்ணனும். So அதனால தான் according to principles of thermodynamics என்ன சொல்றாங்கன்னா, reduction of oxides is very easier. So according to principles of thermodynamics, principles of thermodynamics, என்ன சொல்றாங்க பார்த்தீங்கன்னா, reduction of oxides is easier. Reduction of oxides is easier. Reduction of oxides is easier when compared to other compounds. என்ன கம்பேர் பண்ணும்போது, when compared to other compounds. Okay, so பார்த்தோம்னா, first வந்து concentrate of ore பார்த்தோம்னா, metal is exist in positive oxidation state ல இருக்கும். அது என்ன செய்யணும்னா, reduction well பண்ணி elemental state க்கு convert பண்ணணும். So என்ன சொல்றாங்கன்னா, according to principles of thermodynamics, reduction of the oxides is very easier when compared to reduction of the other compounds. Okay, so அதனால என்ன செய்யணும், before going to reduction, we have to convert oxides compounds, compound concentrated ores convert பண்ணணும். So conversion of concentrated ore, concentrated ore into its oxide, metal oxide முதல்ல convert பண்ணிக்கணும் by using reduction. Okay, so conversion of metal concentrated ore is converted to metal oxides. So the actual common methods இருக்கு. So conversion of ore into oxides. So conversion of ore into oxides. The concentrated ore is oxidized by heating it with the excess of oxygen in suitable furnace. Okay, first என்ன செய்யணும், the concentrated ore என்ன செய்யணும்னா, the concentrated a concentrated ore என்ன செய்யணும் heat பண்ணணும் so concentrated ore is heated concentrated ore is heating கொடுக்கணும் is heating பண்ணணும் by so concentrated ore is heated in so excess of oxygen excess of oxygen in suitable furnace. Okay, so this is the process. For example, lead sulfide. Now, for example, two-step process irukku. The first one, roasting. There are conversion of oxides of ores into oxides. Two process follow panna. One வந்து roasting process. Other one is calcination process. So first one roasting process பார்க்கலாம். Roasting process. So roasting process is used for sulfide ores. Sulfide ore is converted into their oxides. So roasting process is used for sulfide ores converted into their oxides. Okay, so first one pathana, for example, lead sulfide. Lead sulfide is oxidized by heating to form its oxide. Lead oxide and sulfur dioxide is expelled as vapor. Expelled as a gas. Okay, sulfur dioxide is expelled as a gas. Okay, so 2 advanced equation 2. Okay, then zinc sulfide is oxidized by heating to form its oxide. Zinc oxide and sulfur dioxide escape. Okay, so this is 2, here 3, 2, here also 2. Okay, the next one, C2S, and oxidized by heating it to form its oxide, cuprite, C2O and sulfur dioxide. Here 2, this oxidation is 2, here also 2, here 2. Okay, this is the process. So lead sulfide is oxidized by heating it to form its oxide, that is PbO, lead monoxide, and then sulfur dioxide escapes as a gas. And then zinc sulfide is oxidized with by heating it to form zinc oxide 2, and sulfur dioxide escaped as a gas. And C2S is oxidized by heating it to form cuprite, and also sulfur dioxide escaped as a vapor, sorry, gas வெளியில போகுது. This is then roasting process. roasting processல sulfide ores மட்டும் oxidize ஆகி வெளியில போகும், sulfur dioxide வெளியில போகும், அது மட்டும் கிடையாது. So roasting also removes the impurities. Also like so roasting என்ன பண்ணும்? Roasting also removes the removes the impurities. Also. Okay, so what are the impurities? Arsenic, sulfur and phosphorus. Okay, arsenic, sulfur and phosphorus. It is also expelled as a gas. So arsenic is oxidized to form to form arsenic oxide, trioxide, AS2O3, expelled as a gas. And then here 4, 3 and 2. Okay, and then sulfur oxidized to form sulfur dioxide, It is also expelled as a gas. Okay, 8. Okay, and next one, phosphorus. Okay, so phosphorus is oxidized to form P4O10. There is phosphorus pentoxide. Here 5 moles of oxygen to form phosphorus pentoxide. It is also expelled as a gas. Okay, it's oxide. So arsenic oxidized to form by heating it. So arsenic oxidized by heating it to form its oxide, arsenic oxide, H2O3, arsenic trioxide, and sulfur is oxidized by heating it to form a sulfur dioxide, expelled as a gas, and phosphorus is oxidized by heating to form a P4O10. It's also phosphorus pentoxide is also expelled as a gas. It's oxide. Phosphorus oxide is a வெளியில போகும். சரியா? And next one. Next one, a calcination process. Roasting process is over, and then calcination process. Calcination process. So calcination process, calcination process is a concentrated ore is heated in the absence of air. That's very, very important. Okay, the concentrated ore is heated, that's strong here heat pannu. Strongly heated in the absence of air. Okay, so enna pannuna concentrated ore heated in the absence of air. Absence of air. Okay, so first of all, concentrated ore is heated in the absence of air la pannanom. Illa அப்படினா limited supply of air. Limited supply of air. Okay, so limited air supply பண்ணி process பண்ணலாம். இல்ல in the absence of air. சுத்தமா air இல்லாம பண்ணணும். சரியா? So this concentrated ore is heated in the absence of air or limited supply of air. Okay, so water of crystallization present in the hydrated oxides escapes some moisture. Suppose water of hydration present ayirundha, so water of hydration present in the hydrated oxides. Hydrated oxides is escaped as a moisture. Escapes as a moisture. Escapes as a moisture. Okay. And second one, then if any organic matter present, இது மட்டும் இல்லாம ஹைட்ரேட்டட் காம்பவுண்ட்ஸ் மட்டும் இல்லாம வாட்டர் மாலிக்யூல்ஸ் மட்டும் இல்லாம அது கூட ஆர்கானிக் மேட்டர் பிரசன்ட் ஆயிடுச்சுன்னா அது என்ன ஆகும்? எஸ்கேப் ஆகும். சரியா? போர்ஸ் வழியா எஸ்கேப் ஆயிடும். எஸ்கேப் ஆஃப் தி போர்ஸ். ஓகே, ஸோ எனி ஆர்கானிக் மேட்டர் also support present ஆயிருந்தா அது என்ன ஆகும்? escapes in a porous force. கூட அது வெளியில போயிடும். சரியா? So this is the basic one. And then this concentrated ore. So this calcination process carbonate ores can mount pannalam illa hydrated ores ku pannalam. Okay, so first one calcinating during the calcination, during the calcination of carbonate ores. Carbonate ores பண்ணும்போது carbon dioxide expelled ஆகும். Expelled as a carbon dioxide. Expelled carbon dioxide. Okay. So during the calcination of carbonate ores பண்ணும்போது நமக்கு என்ன ஆகும்? Expelled carbon dioxide வெளியில போகும். Okay. Now the process பார்க்கலாம். For example, carbonate ஒன்று எடுத்துக்கலாம். PbCO3, lead carbonate heating, strongly heating பண்றோம். But என்ன? In the absence of air or limited supply of air. So PbCO3 எனக்கு deep compounds ஆகும் இல்லையா? So Pb its oxide and carbon dioxide expelled. And then ZnCO3, zinc carbonate எடுத்துக்கலாம். Strongly heated in the absence of air to form zinc oxide and carbon dioxide expelled here also. And then calcium carbonate is strongly heated in the absence of air to form calcium oxide and CO2 is expelled. Okay, and then dolomite ores, that is MgCO3, CaCO3 is strongly heated in the absence of air to form MgO plus CaO and 2 moles of carbon dioxide expelled from this dolomite compounds. என்ன பண்ணணும்? Strongly heated this compounds in the absence of air or limited supply of air. Okay, so this is the during the calcination of carbonate ores. பண்ணும்போது நமக்கு என்ன ஆகுது? Carbon dioxide வெளியில போகுது, expel ஆகுது, சரியா? evaporate ஆகுது. And then next one, hydrated ores எடுத்துக்கிட்டோம்னா என்ன ஆகும் பார்க்கலாம். Next one, hydrated ores. During calcination, of hydrated ores. Hydrated ores எடுத்தோம்னா நமக்கு என்ன ஆகும்னா water hydrates escaped as a vapor வெளியில போகும், சரியா? அந்த hydrates waters of hydrates molecules எப்படி வெளியில போகும்னா vapors வெளியில போகும். For example, Fe2O3 3H2O. Okay, Fe2O3 3H2O, Fe2O3 plus 3H2O. Water molecules escape out as a vapor. It is not liquid, vapor வெளியில போகுது as a vapor. And then Al2O3 2H2O. This is a bauxite. Yeah, this is limonite, this is bauxite. So bauxite is heated, strongly heated in the absence of air to form Al2O3, alumina. Al2O3 is alumina and 2 water molecules, or the water vapors escape out. Okay, so this is also during calcination of hydrated ores பார்க்கும்போது so water molecules are escaped as a vapor. Okay, so for example, Fe2CO3 H2O is a limonite ore. Limonite ore is a hydrated ore, is strongly heated பண்றோம் and then absence of water, absence of air to form Fe2O3 and 3H2O form ஆகுது. water molecules vapor escape agulu. And then Al2O3 to H2O is a bauxite ore is strongly heated in the absence of air to form Al2O3 and 2H2O. 2 moles of water molecules or escapes as a vapor. Okay, so this is the calcination or during calcination of hydrated ores. This is calcination of carbonate ores. ஒரு சின்ன ரிவிஷன் பார்த்தலாம். So first one, calcination process. என்ன செய்றோம்? The concentrated ore is heated in the absence of air or limited supply of air. Okay, next one, the water of hydration. Suppose நம்ம ஹீட் பண்ணும்போது water present ஆயிருந்தா water of hydration presence in the hydrated oxygen escapes as a moisture வெளியில போகுது. Yes, or any organic matters present ஆயிருந்தா அது pores வழியா வெளியில ரிமூவ் ஆயிடுது. சரியா? So இதுல வந்து calcination process பாத்தீங்கன்னா carbonate ores apply பண்ணலாம் and then hydrated ores பண்ணலாம். Okay, so during the calcination of ores of carbonate ores expelled as carbon dioxide வெளியில போகும். That is, lead carbonate is strongly heated in the absence of air to form lead monoxide and carbon dioxide escaped. And zinc carbonate is strongly heated in the absence of air to form Z&O, zinc oxide and carbon dioxide expelled. And calcium carbonate strongly heated in the absence of air to form calcium oxide and carbon dioxide expelled. And dolomite MgCO3 and CuCO3 is heated and form 2 moles MgO and magnesium oxide and calcium oxide form and 2 moles of carbon dioxide expelled as a gas. And during calcination of hydrated ores, for example, Fe2O3 and 3H2O, limonite is strongly heated in the absence of air to form Fe2O3 and 3H2O, water released as a vapor. And then Al2O3 and 2H2O strongly heated in the absence of air to form Al2O3 and 2H2O. 2 moles of water molecules are escaped as a vapor. Okay, so this is the calcination process. So extraction of crude metals is over, students. Okay, thanks for watching. Thank you.